Hello everyone, welcome to the technical seminar on DApps using blockchain. My name is Nishchadua from Sri Venkateswara College of Engineering from Department of Computer Science and Engineering. In this seminar, we will be exploring the concept of decentralized application (DApps) and their implementation using blockchain technology. We will start by discussing the basic principles of blockchain technology and its relevance to DApps. So these are the contents of the seminar. We'll start with the introduction. Then what are DApps? Next will be how do DApps actually work? Next will be classification or types of DApps. Then advantages of DApps. Next we'll be seeing some of the popular DApps over a period of time. Then we'll end with a conclusion. So let's start with the introduction. Blockchain is a distributed database that allows multiple parties to maintain a shared ledger of transaction without the need for a central authority, as we all know. The transactions are verified and recorded in blocks that are linked together in a chronological chain, forming an immutable record of all transactions. This ensures the integrity and security of the data, making it ideal for applications that require trust and transparency. So, decentralized applications or DApps are a new type of application that are built on blockchain technology. Unlike traditional applications, DApps are not controlled by a central authority, but instead run on a distributed network of computers. A DApp has its backend code running on a decentralized peer-to-peer network. Contrast with this with an app where the backend code is running on the centralized servers. A DApp can have a front-end code and user interfaces written in any languages, just like an app, to make calls to its backend. So what are basically DApps? Decentralized applications, DApps, are digital application or programs that exist and run on a blockchain or peer-to-peer network of computers instead of a single computer. So decentralized applications that run on a blockchain network, these are basically DApps. They are designed to provide an alternative to centralized applications, which are controlled by a single entity and are prone to censorship, data breaches, and other form of manipulation. Data are DApps are built on the principles of decentralization, transparency, and immutability, which makes them more secure and trustworthy. So DApps, which are often built on Ethereum platform, can be developed for a variety of purposes, including gaming, finance, and social media. In the context of cryptocurrencies, DApps run on a blockchain network in a public, open source, decentralized environment and are free from any control and interference by a single authority. For example, a developer can create a Twitter-like DApp and put it on a blockchain where any user can publish messages. Once posted, no one, including the app creators, can even delete the messages. Now let's compare decentralized applications with the traditional apps that we've been using. So when it comes to centralization factor, DApps are decentralized. There's no single point of failure. Whereas in traditional apps, they are centralized and they rely on a central server, which is controlled by basically single central authority. Data storage, DApps is stored on a distributed network, which is blockchain technology, as we previously talked about. Whereas in traditional apps, they are stored on a centralized server. In DApps, there is no central authority or owner or governed by anything involved. It is governed by a smart contract, which we will be discussing later. Whereas in traditional apps, these are owned and controlled by a central authority or organization. DApps is a trustless system. Trust is placed in the blockchain and code, whereas in traditional apps, trust is placed in the organization or developer. When it comes to the security factor, DApps are highly secure due to blockchain technology and consensus, whereas in traditional apps, security is dependent on the central server's security measures. DApps are transparent and auditable due to blockchain technology, whereas in traditional apps, transparency is dependent on the organization or developer. So these are the comparison with the DApps along with the traditional apps. So what are the advantages we'll be getting in the decentralized applications over traditional apps? Next will be characteristics of decentralized applications. Decentralized applications have their backend code running on a decentralized peer-to-peer network as opposed to typical applications where the backend code is running on centralized servers. A DApp can have a front-end code and user interfaces written in any language that can make call to its backend. DApps have been utilized in decentralized finance DeFi, in which DApp perform financial function on blockchain. Decentralized finance validating peer-to-peer transactions to disrupt centralized finance and lower the cost. All the DApps have been identifying code that may only work on a specific platform. Not all DApps work on the standard web browsers. Some of them only just work with the special websites with a customized code adjusted to open certain DApps. The performance of a DApp is tied to its latency, throughput, and sequential performance. Bitcoin system for transaction validation is designed so that the average time for a Bitcoin to be mined is 10 minutes. Ethereum offers a reduced latency of one transaction every 15 seconds. For comparisons, Visa handles approximately 10,000 transactions per second. More recent DApps projects such as Solana have attempted to exceed that rate. So how do DApps work actually? A DApp has its backend code running on a decentralized peer-to-peer network. It can have a front-end code and a user interface that can be written in any language just like it is done for normal applications. The front-end can be hosted on any decentralized servers like IPFS. The DApp working has the following features, which is defined below. They are decentralized. A DApp operates on the Ethereum, which is an open, public, decentralized platform. They are deterministic. DApp performs the same function irrespective of the environment in which they are executed. During DApps can perform any action given the required sources. Isolated. DApps are executed in an Ethereum virtual machine, which is a virtual environment that ensures that even if there is a bug in the smart contract, it won't hamper the normal functioning of the blockchain network. So these are basically the concept or the features of the DApps. These are decentralized, deterministic, Turing complete, and isolated. This is how a DApp actually work. Now there's a term smart contracts have been using very frequently. Let's get to know about the smart contracts. So smart contracts are basically a digital version of such contracts. Instead of a document or a paper, they are a program created on a blockchain like Ethereum. These contracts are also used to create an agreement between users but operate on a trustless basis. This implies there is no need for a trusted intermediary between the parties. The contract executes automatically when its conditions are met. Smart contracts can be used for many other applications, from creating an automatic lending fund to mining special NFTs, which is non-fungible tokens. Smart contracts form the backbone of many complex blockchain applications. Next, we'll be seeing the classification or the types of DApps. So DApps can be basically classified based on whether they can operate on their own blockchain or whether they can operate on the blockchain of another DApp. So by this type of classification, they can be classified into three categories. Type 1 DApp, which operates on their own blockchain network. Blockchains such as Bitcoin, Ethereum can be classified as type 1 DApps. Type 2 DApps are protocols that operates on the blockchain of a type 1 DApp. These protocols themselves have tokens that are required for their functions. Type 3 DApp, these are basically protocols that operate using the protocol of a type 2 DApp. Similar to type 2 DApp, type 3 also have tokens that require for their function. So there's another way to classify decentralized applications. which is by their purpose. So there are three majorly purpose, which are financial, partially financial, and non-financial. So let's talk about financial apps. They give users the tools to manage their finances, both fiat and crypto. They help users manage their savings, wills, and many more things, etc. Second one is partially financial apps. They involve working with the money, but that isn't their primary purpose. Examples of these bonus Example of these are basically bonus and point system within loyalty programs as well as gambling apps. Third one is non-financial apps. Such programs have nothing to do with the money at all. These can be service for personal identification, conducting polls and voting. These are basically decentralized file storage and many more things. So let's talk about advantages of DApps over traditional apps. The main benefit is censorship resistance. With no single entity or authority involved in controlling the DApp, it is very difficult for any one individual or government to control or restrict the access to the DApp. Open source. DApp are open source. This encourages faster and more secure development of the ecosystem. Cost reduction. Unlike centralized systems which requires a high installation cost of the server and experts to manage and maintain the server, the decentralized application eliminates the cost of the network. These are highly autonomous. These applications are considered to be more secure when compared with traditional applications. These applications do not face any security breaches as they do not have any central structure from which threat occurs. Thus, decentralized application seems to be more secure as the creator cannot the flow of the network. So these are some of the advantages that we've been seeing. First one is open source. Second one is cost reduction. Third one is highly autonomous. Continuing with the advantages. Next one is fault tolerance. If a single node in the network is still working, a decentralized network can stay available, although performance may be severely downgraded. Because there is no centralized network, a hacker would not likely to be able to attack enough network of nodes to take down a DApp. Data integrity. Data stored on a blockchain is immutable and secure because blockchain consensus algorithms ensures data stored in the blockchain is resistant to change. Next one is flexible platform. The Ethereum blockchain is flexible enough to enable the quick move developments of DApps for different industries. User privacy. Users do not need to submit their personal information to DApps to use any app specific functionality, which is a main and major advantages over traditional apps. So these are the advantages that we've been discussed. Now let's look on the challenges that we've been facing while using a decentralized application. First one is immutable. So it can have some disadvantages also. The smart contracts are developed by humans, and as a human error is unavoidable, these DApps have a high potential to become a huge problem too. Its slow speed. In the decentralized system, it occurs in some transactions are delayed in the process. This adds lags time to the process which is executing in the network. This becomes the sole reason for the business not to rely on a decentralized application. The network can only process around 10 to 15 transactions per second. Third one is hard to find or hard to use. It is as end user as the average end user finds it too difficult to set up the necessary stack to interact with the blockchain in security manner. To make it somewhere user friendly, one solution is to build a base layer on the top of the apps which ended up as a centralized app. Next one is its hard maintenance. The apps are as difficult as it is hard to modify the code and the data published on the blockchain network. Once the DApps are deployed, developers also find it hard to make changes even if the bug is identified. Continuing with the challenges, next one is performance overhead. There is a huge problem for the performance overhead, and scaling is very difficult. To achieve the level of security, integrity, transparency, and reliability that Ethereum aspires to, Every node processes and stores every transaction. On top of that, proof of work takes a lot of time. A back of the envelope measures puts the overhead at something much longer that of a standard computation currently. Next one is network congestion. When one DApp uses many computational resources, the entire network gets backed up. Currently, the network can only process 10 to 15 transactions per second. If transactions are being sent to faster than this, the pool of unconfirmed transactions can quickly balloon. So these are the challenges that we face while using our DApps. Now let's see some of the popular DApps which have been developed over the period of time. So first one is OpenSea. OpenSea is a peer-to-peer marketplace for digital assets, basically like non-fungible tokens (NFTs). It allows users to buy, sell, and trade a variety of digital collectibles, including cryptocurrencies, game items, and other digital assets. The platform uses blockchain technology to ensure the security and transparency of all transactions. OpenSea has seen its fair share of highs and lows also, like obtaining a valuation of $13 billion and coming under fire insider trading and phishing attacks amounting to losses over $1.7 million. Still, with more and more people like celebrities, businessmen, and many more looking to launch their NFTs, the marketplace is only set to grow this year. Next one is MakerDAO. MakerDAO, founded in 2014, is dedicated to solving the volatility concerns associated with cryptocurrencies. It is a popular DApp known for its token DAI, a stablecoin pegged to US dollar. To receive a loan, borrowers provide crypto assets which are secured in the smart contracts as collateral. Once the loan is repaid, the borrower receives their crypto collateral back. Third one is Curve. This is launched in early 2020. Curve is a DEX that allows users to trade a variety of stablecoins in a single pool. It supports major cryptocurrencies such as Bitcoin and Ethereum, and stablecoins such as DAI and USDC. One of its key features is that it's low slippage, which means that users can get the best prices when trading, as the order book, which is the list of buy and sell orders, is always updated in real time. Slippage refers to the difference between the anticipated trading price and final trading price. So it is very low slippage. That's the advantages of using Curve. So slippage basically refers to the difference between anticipated trading price and final trading price. Next one is Uniswap. This is launched in 2018. Uniswap is a decentralized cryptocurrency exchange (DEX) built on Ethereum. It uses automated liquidity pools to bring buyers and sellers together without the need for a third party. This makes it possible to trade any ERC20 token, which is one of the most significant Ethereum tokens which has emerged as the technical standard. It's very popular for its low gas fees and fast transactions. In April 2021, Uni, the platform's governance token, was the fourth largest cryptocurrency by market cap on Coinbase with a valuation over $18 billion. So let's come to the conclusion. The potential for DApps to change the way we interact with the technology. So decentralized applications have the potential to change the way we interact with the technology by offering greater transparency, security, and user control. With the rise of blockchain technology, DApps can enable decentralized governance, trustless transactions, and transparency, providing several benefits over traditional centralized applications. DApps can reduce transaction fees, eliminate intermediaries, and provide greater accessibility to people who do not have access to traditional financial services. They are also enable greater participation, collaboration, and innovation, making it easier for developers to build new applications and services that can benefit society. DApps can be used in various domains such as finance, gaming, social media, supply chain management, and many more offer several opportunities for disruption and innovation. So while building a DApp, you need to consider factors such as scalability, security, and user experience. Scalability is important because blockchain networks can become congested, leading to slower transaction times and higher fees. So security is a crucial for benefits for the development of DApps because DApps are prone to attacks and vulnerabilities, which can lead to the losses of funds or data. User experience is also important because of DApps that should be easy to use and navigate even for a non-technical users. The need for ongoing research and development to overcome challenges and maximize the potential of DApps. So while DApps offer several benefits over traditional centralized applications, they also face several challenges that need to be addressed to maximize their potential. One of the main challenges is scalability, as blockchain networks have limited transaction processing capabilities, which can result in slow transaction time and high fees. Another challenge is user adoption, as many people are still not familiar with the concept of blockchain technology and the concept of decentralized application. Additionally, these are issues related to interoperability, regulation, and security that need to be addressed to ensure the success of DApps. To overcome these challenges, ongoing research and development are required to improve the scalability, usability, and security of decentralized application. New technologies such as sharding, sidechains, and layer 2 solutions are being developed to address the scalability issues, and user-friendly interfaces and education programs are being developed to increase user adoption. The blockchain technology or the blockchain industry is still in its early ages, and there is a lot of potential for the innovation and growth, making ongoing research and development critical for the success of DApps. So in conclusion, DApps are a powerful way to create decentralized applications that are secure, transparent, and trustworthy. By leveraging blockchain technology and smart contracts, developers can build a wide range of applications that can disrupt traditional industries and create a new opportunities for innovations. However, building a DApp requires a deep understanding of blockchain technology and its underlying architecture, as well as a commitment to security, scalability, and user experience. So that's all. Thank you.